Dr.S.Nazarath, and today I will be talking about magnetic materials, which are an important part of our daily life and modern technology. Magnetic materials are substances that show a response when a magnetic field is applied. The magnetic behavior arises due to the motion and spin of electrons inside the atom. Even though this effect occurs at the atomic level, they produced powerful result that we can observe and use in everyday applications. Based on their magnetic behavior, materials are classified into diamagnetic, paramagnetic, ferromagnetic, antiferromagnetic, and ferrimagnetic material. Among these ferromagnetic materials such as iron, cobalt, and nickel are widely used because of their strong magnetic properties. Magnetic materials are essentially in many devices we use every day, such as electric motors, generators, transformers, loudspeakers, and data storage devices. They are also used in advanced fields like medical imaging and modern electronics. By studying magnetic materials, we can understand how magnetism works and how to develop better and more efficient technologies. In this session, we will learn the basic concept and importance of magnetic materials. The first magnetic material is diamagnetic materials or substance. They are weakly repelled by an external magnetic field. When a magnetic field is applied, they develop a very small induced magnetic moment in the opposite direction to the applied field. Characteristics of diamagnetic materials: they are weakly repelled by magnetic field. They do not have permanent magnetic dipole moments. Magnetic susceptibility is negative and very small. Relative permeability is slightly less than 1. Magnetization is very weak. Magnetization disappears immediately when the external field is removed. Their magnetic behavior is almost independent of temperature. In a non-uniform magnetic field, they move from strong field region to weak field region. Examples: copper, silver, gold, silicon, water, quartz. The next magnetic material is paramagnetic materials or substances that are weakly attracted by an external magnetic field. When a magnetic field is applied, they become weakly magnetized in the same direction as the applied field. Characteristics of paramagnetic materials: they are weakly attracted by a magnetic field. They possess permanent magnetic dipole moments due to unpaired electrons. Magnetic susceptibility is positive and small. Relative permeability is slightly greater than 1. Magnetization disappears when the external field is removed. Their magnetic behavior depends on temperature, obeys Curie's law. Therefore, psi is directly proportional to 1 by T. In a non-uniform magnetic field, they move from weak field region to strong field region. Examples: aluminium, platinum, chromium, manganese, and oxygen. The third magnetic material is ferromagnetic materials or substances that are strongly attracted by an external magnetic field and can retain their magnetization even after the external field is removed. They exhibit strong and permanent magnetism. Characteristics of ferromagnetic materials: they are strongly attracted by a magnetic field. They possess large positive magnetic susceptibility. Relative permeability is much greater than 1. They show hysteresis behavior. They can retain magnetization even after removing the external field. They can be permanently magnetized above a certain temperature called the Curie temperature. They are lost their ferromagnetic property and become paramagnet. Example: iron, nickel, cobalt, and steel. The next magnetic material is antiferromagnetic materials or substance in which the magnetic moments of adjacent atoms align in equal magnitude but opposite direction, resulting in zero net magnetization in the absence of an external magnetic field. Characteristics: magnetic moments are aligned in opposite direction. Net magnetization is zero in the absence of magnetic field. Magnetic susceptibility psi is very small and positive. They show magnetic ordering below a certain temperature is called the Neal temperature. Above the Neal temperature, they behave like a paramagnetic material. They do not retain magnetization after removing the external field. Examples: manganese oxide, nickel oxide, iron manganese, and chromium. The final magnetic material is ferrimagnetic materials or substance in which the magnetic moments of atoms are aligned in opposite, that means anti-parallel direction, but the magnitudes of the moments are unequal, resulting in a net magnetic magnetization. The characteristics of ferrimagnetic materials are: magnetic moments are aligned antiparallel but unequal. They possess net magnetization. Magnetic susceptibility psi is large and positive. Relative permeability is greater than 1. They show hysteresis behavior similar to ferromagnetic materials. They can retain magnetization above a certain temperature is called the Curie temperature. They lose ferrimagnetism and become paramagnetic. Example: magnetite, ferrites such as manganese zinc ferrite, nickel zinc ferrite, and magnesium ferrite. Understanding magnetic material is not only important from a theoretical point of view but also from a practical perspective. They play a crucial role in electric motors, transformers, generators, data storage devices, sensors, medical imaging equipment, and many advanced electronic applications. Emerging fields such as spintronics and magnetic memory devices further highlight the importance of studying magnetic materials. As the research continues, new magnetic materials with improved efficiency, higher stability, and better performance are being developed. This makes the study of magnetism a continuously evolving and exciting field in physics and material science. I hope this session has proved a clear understanding of the basic concept and classification of magnetic material. Thank you for your kind attention and interest.